Every time I see crappy code, I'm a mushroom cloud-laying motherfucker. I'm Superfly TNT. I'm the guns of the Navarone. In fact, what am I doing cleaning up your crappy code? You're the motherfucker who should be on brain detail. We are fucking switching. I haven't seen Pulp Fiction in many years, but I saw it again recently, and this describes quite accurately how I feel when I look at crappy code. So my name is Magnus Petersen, and this is going to be a code review video. In my tutorial number 19 for TensorFlow, I am using something called scikit optimize, and I had to rewrite most of the plotting functions and a few other things. And there were so many problems with this code that I thought instead of making a long rant inside my tutorial number 19, I would make a separate video instead, because I think that some of the things I have to say here will be useful to a lot of other programmers who don't necessarily use TensorFlow or even Python. Now, scikit optimize is a fantastic tool, but the implementation is not very good. And there were so many problems in this one single file that we're going to see in a moment that I thought it would make an excellent video on this topic. So I'll show you what is wrong and how I cleaned it up. And it's probably not going to be very fun to be the developers who actually made this and have to sit and listen to this. I'm not even sure if they're going to do it. But first of all, I spent a week cleaning up their crappy code, so I have earned the right to criticize it. Secondly, they all have PhDs. One of them is even a teacher, and another one is working at the Google Brain team now. And a third one, I think he has worked at CERN, which is like a physics lab in Switzerland, I think. I don't know anything about physics. I think it's something with little atoms floating around in the air, and an atom is a little ball, so they have like little balls floating around the air. Now, I don't have little balls floating around the air, so I don't know what that is. Now, before we get started, you're probably thinking, who is this clown and why is he teaching me how to code? So just briefly, a little about whether or not I can code and whether I can debug and so on. When I was in high school many years ago, I used a tool called Soft Eyes. It was a little hobby I had that I would debug commercial programs. And the way you would do that is you would have a debugger like this, and it would run, as I remember, it would run between the CPU and Windows, pretending that it was the CPU, but this meant that you could break it at any time you wanted, unless the program had made countermeasures so you couldn't do that. Then it got a lot more difficult. What you see here are the registers for the CPU, and here you have the stack pointer, and I think this is called the base pointer, and here you have a memory dump, and here you have the code that is actually running, and we have stopped it right here. This is just a screen dump from some internet page, because I haven't had this program running for 20 years, and I don't have it anymore. And what you see here is called machine code. So this is what the machine sees in a compiled program. It sees these hex numbers over here, and these actually have meanings. So for example, move one register to another, push something, move something again, compare two numbers to each other, jump if the comparison was non-zero, which means they are different somehow, and so on. So this is really hard to understand. And I actually made the first cheat for Quake. I never released it, but I made it. And this was when I was in high school. I had a dial-up connection to the internet. So not only was it expensive, but I had to be really quick because otherwise my modem or my internet service provider would think that my connection had been disturbed somehow and then it would disconnect. So when you go into this debugger, it completely freezes the computer and the modem and everything else. Nothing else is running. I had to be really fucking fast. Maybe I had 30 seconds in here, find out what was happening, continue running the program. I managed to get the cheat running for Quake, but I didn't have a GPU, so I only had like a frame rate of like 5 per second. And my friends also didn't play this game. So for some stupid reason, I never released this cheat. I couldn't really test it properly. And so I wasn't so happy about releasing it, I guess. I can't remember. But what I'm trying to get at here is that at least when I was young, I was a pretty fucking good debugger. And I could understand very low-level code. Another thing I just want to mention is that I actually don't like the word code. When people talk about programming in Python, that is programming. This is code. This is code. This is code. And when you would program at this low level, you would do it in what is called an assembler. And there you had additional language features, but it looked pretty much the same. You wouldn't normally use registers directly. You would use variable names, and you could also make labels. And I can't remember if you could make functions, but you could certainly jump to labels. So it was slightly easier when you wrote assembly code, but it was still not easy. But I did it, and I was pretty decent at it. So on the other end of the spectrum, I want to briefly show you this. This is something I did maybe 10 years after I did the Quake cheat. And this is very advanced programming in C++. And in order to do this, I actually had to invent several new programming techniques. This library I made called ArrayOps was somewhat similar to a library that you might know called Blitz++, but mine was far more elegant. And when I had made it, I wrote this manual. And just to show you a quick example of what that code looked like and how well I had polished and documented it, this just takes a slice of an array and initializes it with some values. I haven't programmed using this for like 12 years, and when I browsed my manual for let's say 10 or 15 minutes, I sort of understood it again, and that was only because it was so well documented. Now, unfortunately, I don't think ArrayOps was ever used very much. I think maybe it was used for teaching advanced C++, but I don't think it was ever used in production very much. So now we get to the code that I'm going to talk about. This is from the Scikit Optimize library. And once again, it's a fantastic tool, but it's a crappy implementation. So let's look at the plotting functions. And I have rewritten almost this entire file, and I'm going to show you before and after. So we'll just walk through this, and when we stumble upon something that is not very good, we'll discuss it. And there's going to be plenty. So we start with this. Def format scatterplot axis. This comment here is actually for what is going on here. It is not for the function. So already here we are missing a docstring. You don't know what the semantics of this function are supposed to be, what the original author intended for this function to do. This means you have to go into the function, read what it is doing, and then if you can understand it, if you can, then you code assuming that what it is doing now is what it's supposed to do. If the original author had made a bug or a mistake, so it in some way did not behave the way he had intended, suddenly you have different people using this function, and they all have different ideas of what it is supposed to do. So when I see this, I'm a mushroom cloud laying motherfucker. You are pissing me off that you don't document what your function is supposed to do. It is easy. Boom, boom, boom. This function is supposed to do blah, blah, blah. You write 5 lines, end of story. Because you might say, oh, the name is so long and fantastic and it explains everything. Fuck you. This name is wrong. This function does not operate on scatter plots, alright? It operates on 2-dimensional matrices of plots in matplotlib. So another problem is that you don't know what these arguments are supposed to be. X. What is that? Is it a hatchet? Space. What is that? Is that like outer space? Is that like a spaceman? Y label. Dim labels. We don't know. Okay, so let's move on. This comment here is probably one of the best comments in the whole file. The only real complaint I have with that is that there's not a dot at the end. Comments should be English sentences, alright? An English sentence starts with a capital letter and it ends with a dot. If you had it like this, then it's not an English sentence. I don't know if this is really continuing something you explained above and whether the explanation continues further below. When it is written as an English sentence, you know this is the beginning of the sentence, this is the end, this is what it explains. So always write comments as proper English sentences. Okay, so let's look at this code here. Diagonal ylem. So now we're lucky. We have a small comment and you'll see this is lucky because the file is pretty much uncommented. But what the fuck is this doing? So it starts by wrapping something in a parenthesis. So this is maybe creating a tuple? I'm not sure. Then we have np-min. This is numpy minimum. But then we take xi,i.getylem, and then we have like a list indexing for 0, and then we have for I in range space.endims, and this is what is called a list comprehension in Python. Nobody understands what this is doing. Yes, if you spend 10 minutes, you can deduce it. How are you going to debug this? You cannot step debug this. The solution is very easy, alright? We make a function, and I have made that function here. And we have a docstring that explains Get the min-max of the y-lim for all diagonal plots. This is used in adjust fig, so the y-lim is the same for all diagonal plots. Boom! Now you know what this function is supposed to do. Parameters, ax, matplotlib axis. Two-dimensional matrix with matplotlib axis objects. Returns, y-lim diagonal, the common min and max y-lim for the diagonal plots. If you are still confused, you can go in and look at the code. Let's do that. Now this does exactly the same as the code you saw before. The only thing I have done here is that I have sort of unrolled it. I have flattened it so that each line does something. I haven't combined 10 different things in a single line. Do you remember those competitions back like, I don't know, 20 years ago? Who could write the shortest program in C? And some guys could write, a complicated algorithm and never even press enter. They wouldn't have any new lines in the code at all. That's fine for a competition in nerdery. It is not fine in code that other people are going to look at and debug and maintain, alright? Now, the way I like to write this is I like to give each code line a bit of space. And again, I don't like this word code, okay? We're programming here, but you all say code, so, you have polluted my vocabulary. Fuck you. Anyway, you should generally avoid to have many nested function calls, alright? Normally, I'm perfectly fine using the variable name I or j or k when we're iterating over something. The reason I use row here is that I want it to be consistent with code I have further below, where I use row and column. And I'll get back to that in a moment. Now this one, for example, zip star ylim, that's a Python specific thing. And this list comprehension is as well. But both of them, if you're new to Python or you're not really an expert, it really helps a lot that you have a comment. And these comments don't hurt, alright? You don't have to pay like real estate taxes because you added a line of comment in your GitHub repository. It doesn't work like that. If you don't have comments, it's like drunk driving without safety belt. Maybe 9 out of 10 times nothing happens, but when something happens, these comments are really gonna help you. And also, when I read code, okay, this is another thing I want to tell you. I don't read the code when I read my old stuff. If I read something I wrote 10 years ago, I just read the comments. I read English. Doody-doody-doo. Number of search phrase, blah, blah, blah. Get ylim, separate, min ylim, blah, blah. The common ylim, return it. Personally, I get confused if I have to switch between code and comments. I prefer just to read comments. And then if there's a problem, I find out from the comments what is the intended behavior here? And then I look at the code and say, oh, there's a problem with the code. It's not doing what it's supposed to do. So another thing I want to say is that I don't like it when comments are written like this. To me, that is aesthetically unpleasing, let's say. I like that the lines of code have some air between them, but you can group statements together that are very closely related. So for example, you could just have it like this. And then you could write the comment like this. Now you know that this comment refers to these two lines, all right? If you have it like this, you don't really know what this comment refers to and what this one refers to. Does it only refer to the line that follows? Or does it refer to all 3 lines? Or all of this? You don't really know. And that's why I like to have these line spaces and the comment on top of each of these code lines, so that now we know what belongs to what. This is so easy to read. Okay, so let's go back to the original code and the function we were looking at before. So what we just did was we fixed all of this, and we made it into a function that you can easily understand and debug and maintain. Now the next lines here I'm not going to go into because all of this is removed in the code that I have made. This is no longer relevant. So let's move on to these nested for loops. Deal with formatting of the axis. Alright, here we have the rows and here we have the columns. So there are a few things here. First off, why not write row and column? When you get further into the code and you have all of this, if I is different from j, and especially because when you have these multi-dimensional arrays, some libraries exchange the order. They could be row first or column first. So I find it more convenient or more clear to write row and column. And especially because I always forget this. I can't remember if it's row first or column first. So if you look at my code, you can very easily see, oh, Magnus thought that this was a row where it's supposed to be a column. So he made a mistake. Fine. Okay, let's change that. So the second thing I want to say is that if you are making a reference to something inside an object, and you do that many times, like you do with endims here, you do it here, and you do it further below as well, then why not take the variable out like this? So we can just write endims here, and then we make a little comment, number of search page dimensions. And fuck you if you don't like my English language. No, actually, I got 3 comments so far on YouTube that people think I have a sexy voice. And they're all Asians. I don't know, maybe I should go to Asia. So anyway, and then we don't have to write rows and columns here anymore, because now we know row and column. Then we have another thing here. This is funny. So we have X, which is a 2-dimensional array, or a list of lists, or whatever, that we get in as an argument to this function. In this scikit-optimized library, whenever they need a temporary variable, they give it the same name with an underscore at the end. Ding, ding, ding! Is this dangerous or what? Now, I managed to track down that this is a naming practice that comes from scikit-learn. And in scikit-learn, this means that it is a variable that has been fitted somehow from the data. Alright, in scikit-learn everybody knows that that's the semantic meaning when the variable name ends with an underscore. I still don't like it. I think it should have been called axFitted or whatever in scikit-learn, because it is so easy to make a mistake between x and x underscore. And when you're looking through the code and you have been working on this for 7 days and 22 million hours every single day, and you just can't find a bug, and then suddenly you realize, oh fuck, I forgot to put an underscore. This is really, really dangerous programming practice. And actually it gets worse. Let's look at another file in this project. So here we have something called nInitialPoints. I guess it's the number of initial points. We assign that to 2 variables in the object. One of them has the underscore at the beginning and the other one has it at the end. There's no comment what the fuck these mean, alright? No clue whatsoever. So you have to read all the code and see where this is used to find out what is intended with this. And again, then we go back to poor documentation. 7 different people will think 7 different things, and suddenly your code is a huge mess because the semantics are not clear. And let's take another example in another file in this project. They have something which is like a mathematical thing that I don't understand, but then we go down and it says that something, something, something is pre-computed as the attribute alpha underscore. Notice the underscore. What the is the matter with you? Now, maybe this is a problem with your computer. Now, I have a fairly new computer, alright? On this computer, I have 2 keys. One of them is called delete, the other is called backspace. I also have Ctrl, and I have Alt. I cannot find any key, but I rarely ever need it. So that's alright. But in this case, I only need backspace or delete. You delete it and you write a new fucking name. How hard is that? You don't make a comment here. And again, these guys are so stingy with comments. And you will see that as we get further. They almost have no comments in their code. They find it necessary to warn you that their choice of variable name is so bad that you have to be careful. What the fuck, guys? What the fuck? Alright, so let's go back to plots.py, our favorite Python code in the whole wide world. So what's the next problem? Nesting. And I'm not talking about spooning, and I'm not talking about the nesting instinct or whatever you think this word might mean. I'm talking about having for loops within for loops within for loops within if statements within for loops within for loops within while. We could make a little rap here. Alright? It gets worse. Let's have a look. So let's count the nesting depth. Alright? I need to have my big calculator out here. Just a moment. Okay, I'm counting now. 1, 2, 3. 3 again. So let's change this back so we don't get too confused. So we are looping over for I and j. So if j is greater than I, we do something axis off. I don't really know what that is, so let's press Ctrl B and we get up a list of functions that it could be. Because Python is not strong typed, it is not sure what this axis is. So we get this whole list of what it could be. And this is also what I'm talking about when I write comments, alright? I would write something like this. Turn off plots above the diagonal. Everybody understands what this means. You don't need to know the Matplot API to understand this. Then we have a comment here. This comment I don't like. Even better would have been written to write a real sentence. Process the non-diagonal plots. Like that. Oh, and then look at this comment here. Look at this comment here. Again, and I find with very few comments, they have taken the time to write a comment like this. Plots on the diagonal are special, like Texas. They have their own range, so do not mess with them. I had to read this at least 5 times until I understood that this was most likely a joke, but I'm still not 100% sure. It is not funny. You do not write jokes in code comments unless your father was Groucho Marx and your mother was Bruce Lee, alright? That's how good you have to be at coding and at making jokes if you're gonna make jokes in code comments. I don't do it because I can't pull it off. What if somebody in Timbuktu or Bangladesh reads your code and they're not very good at English? Or the sense of humor is very different, like it obviously is here. I don't think this is funny at all. Then they won't understand what you're trying to say here and they just get really confused. So don't write jokes in comments. It's not funny. But let's continue with the nesting depth. I can't remember. What did we get to? 1, 2, 3. Now we have another one. 4. So I'm not sure. Why is this if j is greater? What is this doing here? So this is setting the y-tick labels to nothing if j is greater than 0. And what was j? Oh, I deleted that. This is columns. And this is rows. So if the column index is greater than 0, set the tick labels to nothing. Otherwise, set them to the dim labels. I wonder what this is supposed to be doing. So let's move on. This just continues with the same crappy code style. And down here we have even deeper nesting. Alright? We even have a zip in here. And another if. I mean, what the... And then at the end here we have an else. And we have all of this crap. And you really need to know matplotlib very well. Because otherwise you have to look up what each of these function calls is supposed to do. And you might think that my style is excessive. Now let's go over and have a look at mine. So first of all, I call it adjustFig, alright? And I write a little docstring, process and adjust a 2-dimensional plot matrix in various ways by writing axis labels, etc. This is used by, and I think this is a nice thing to know. And yes, if you use PyCharm like I do, it has functionality so that you can track down using the IDE where is this function actually being used, but it's nice to have it in the docstring so you know how things fit together. And you get the parameters, or we pass in a fig and an x and search space and so on. Let's look at the code. So remember the function we made before for getting the ylim for the diagonal. Okay, so now we can just call it like here. I still write a comment line because there's no need for you to go up and read the docstring for this function. There are some IDEs where if you hover the mouse or something over the name, it will automatically show you the docstring for that function. I don't think PyCharm is doing that, but even so, I find it helpful if we just write a line and say, in English, what is this line of code doing? And then I explain here why I have chosen the following way of processing the stuff that we're going to work on in this function. And the main reason is that it is much easier to understand instead of having these nested for loops that you saw in the original code. But why do I write this? Because if you wonder why I did it this way, you now know there is a reason. This reason could be many other things. It could be related to performance. It could be related to memory usage. It could be related to a lot of things. If I don't write it down, this reasoning is lost. And maybe there was some profound knowledge. There's not really here. I'm just explaining why I did it. But maybe there is a profound insight and a profound lesson that if you 5 years from now decide to write this differently, maybe I can tell you here in the comments that, you know, I already tried this and it didn't work so well. So that's why I did it like this. So I have split it in different for loops, so we don't have the big nesting depth, because it is really hard to understand when you have a lot of nestings inside each other. So again, every line of code, I have a comment that explains in English what it is doing. And it is like there is this culture amongst coders that you are somehow weak if you need comments. But let me tell you this, having code that looks like this does not mean that you have a huge cock or a huge brain. I don't think anybody in the history of nerdery has ever gotten laid by saying to a lady, "Hey, Miss Lady, I code without comments. Do you want to see my stamp collection?" I don't think it works. Let me know if it does. I'd like to know. The reality is that if you code like this and don't want to explain what it is you're doing so that others can understand it very easily, it is either because you are lazy or you are arrogant and you don't give a scheisse about who is going to look at your code next. I probably spent a week rewriting this file. It was broken if you gave it a certain type of input. If it had been written properly and documented and commented properly, I could probably have fixed it within a day, perhaps, but instead I had to spend a whole week doing it. And that was because it was just hard to understand what the code was even doing, compared to code that looks like this. So yeah, first we process the plots on the diagonal, blah 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 blah, and instead of nesting something inside here, we could have done that. I choose to have the same for loop again, so that I can clearly write in the comments and say, now we are processing the plots below the diagonal, and then we have a nested for loop here. So first the row, then the column, and it does a number of things, and plot a grid, and set the plot limits, and blah blah blah. All of this you can understand without knowing anything about Matplotlib, because it is explained in English. When that is done, we go to the next thing. We turn off all the plots to the upper right of the diagonal. And here we have a slightly different indexing. So if I wanted to nest this inside these for loops up here, it would start to become a little ugly. It is a lot better to say this is a separate section and this is what it's doing. It's turning off all the plots to the upper right of the diagonal. And yes, there is a little redundancy in some of the code, but this is not performance critical code. So it is far more important that this code is easy to understand and maintain and modify than it is to nest all the for loops so we squeeze out a few lines of code. And it continues, and I have several others that are quite similar. Here is another little detail. You might say, oh, let's just say, instead of having column variable here, let's just put the 0 here like this. I don't know. I think this is better because this clearly specifies that we want the column index to be 0. I think this is easier to understand. But the thing with all of this is commenting style and how much or how little should you do and how do you write good comments and so on. First of all, it is a matter of personal taste. It's not right or wrong. It's a spectrum between horrible or non-existing comments and really good comments. And we can't even agree on what would be an appropriate level of commenting. Some of you hate my style because you think I overdo it. But those people who don't program Matplotlib every single day and don't know all the API calls, they can understand this within minutes. Compared to this code over here, and this stuff up here, which is just a mess. Even with comments, this would still have been a mess because of the nesting. Okay, so let's move on to the next function called partial dependence. And it does have a docstring, but it doesn't really explain that well what it is supposed to do, or maybe a link to an article on Wikipedia or something like that. I'm not a statistician, so I don't know what this is. I've never seen this before. The only way I could figure out what this was doing was to read the actual code. So let's have a look. Oh, and I should just mention here that these XXX comments, I've never seen these before. So I thought XXX was like the author's note to himself that he needed to fix something here. Because the only meaning of XXX that I know is hardcore pornography. And I think that is common knowledge before you call me a pervert. Alright? But I looked it up and it appears that XXX actually is used as a comment that is a warning that you really have to be careful with this or something like that. That is not the case here. This is something that needs to be fixed in the future, so the appropriate one would be to do. But I'm not even sure that there's any point in having this. This is up for debate. I don't think this is a very helpful comment, especially when the rest of the code is not commented. So it has these two cases, if J is none or otherwise. And it calculates something that looks quite similar, but it does it in 2 dimensions down here. Now, this is not the Pythonic way of doing it, and I'm not a Python expert, but I do know that if you have something like this, what you use is called a list comprehension, and I will show you in a moment how this is supposed to be done. Another thing is that it's generally a bad practice of adding to lists like this. This is a dynamic list, which means that it grows as you add elements to it. And the way this is implemented is that to avoid that it has to allocate a whole new list every time you add a new element, it allocates a lot of extra elements every time it needs to grow it. So it only needs to grow the list once in a while. The result is that you get amortized, constant computational time for each addition to the list or append on the list. But that does not mean it is just as efficient, both in terms of computation and memory, to pre-allocate a list of the length that it needs to be. But that is not very good practice in Python either. The real way to do it is to use a list comprehension, as I will show you in just a moment. Now, there's another thing here, which is to return inside the body of the function. In general, I am not so happy about this, but sometimes I do this as well. And it really has to be justified. In this case, it is because the function can operate on either 1 dimension or 2 dimensions. And so we can return either this or this. And I have added a function to TensorFlow, I think, where I do something like this. Of course, my code is beautiful and this is not, because they do that quite often in TensorFlow. But you need to be careful when you return inside a function body, because it's very easy to be confused about the control flow of the code. Now, I have split this function into 2 simply because the body of the function became quite long when I rewrote it. So I have one partial dependence function for 1 dimension, and I have at least tried to give a better docstring. You can be the judge if that was successful or not. And we have the body of the function here. I have basically just cleaned up the code in the other function, and I have commented what all of the lines are doing so that you can understand this very easily without knowing any of the API calls or very much about how this library works. And down here we have the so-called list comprehension. So I have made a helper function because it has to do quite a lot. But where we generate this list that we have to return is now a very simple line. And you can clearly see that it is looping over this xi transformed, and it is calling calc on every single one of them. And you can probably simplify this even more by using other Python tricks or NumPy tricks, so that you would call like a mapping function that would take a lambda function or whatever, something like that. But this is easy to understand for even fairly new Python programmers. And then the function that we're actually looping over does the following. And again, I explain what everything is doing, so you don't really have to understand the code unless there's a problem or unless you want to modify it somehow. All you have to do is read, copy the samples so we don't destroy the originals, set the indexed dimension to x for all the samples, calculate the predicted objective value for all samples, and then we get the average predicted value for the objective function, and then we return it. Personally, I think this is a lot simpler. This is something you could understand in 5 minutes, whereas the other one probably took me some hours to figure out what the hell it was doing. Here we have the 2-dimensional version, and again we have a helper function for doing the actual calculation. Now it takes 2 variables, x and y, but otherwise it's quite similar. And what follows is also quite similar, except now we have 2 dimensions. And then we have this list comprehension within a list comprehension. And again, there might actually be a simpler way of doing this in Python. I'm not really a Python expert, but this is still very easy to read. We have one for loop that goes over x, and we have another for loop that goes over y. And for every single possible combination, we call this helper function. And out of this, we get a list of lists. And then we call NumPy to convert it into a NumPy array. And then we return it. Boom, done, clean, simple, easy, beautiful. And now let's look at the original code again. So we have another function here, plot objective, and this is what the code looks like. And obviously, once again, it's a complete lack of comments. And then you have, for example, here space.transform, and then a nested function called space.rvs. I don't know what that is. So let's push Control B. Boom. What the? It's about 200 million different function calls, and a lot of them seems to be coming from SciPy. I'm not really using SciPy. Maybe this library is using SciPy, I don't know. So how am I gonna find out what this space.rvs is doing? And then it calls space.transform. Let's do Control B again. And again, this problem is caused by Python having weak types, so it doesn't really know what type space is. It could be anything. Now let's look at how I wrote this code, okay? So this is my code, and this is how I rewrote that line of code in the original file. So here you don't have to look up the API calls because I tell you in English what it is doing. Get new random samples from the search space and transform them if necessary. Now there's something else I want to say here, because I think usually when RVS is called, often they call transform as well. I don't know if this happens every time, or if there's some reason where in some case you might not want to do it, but if this is always done, then transform should be a part of RVS. Okay, so this is apparently a function name that is typical in SciPy or whatever, but I don't like that name very much. What is it? Random variate sampling something? I don't know what it stands for, RVS. It's a bad name. I don't like the SciPy API, by the way. But anyway, if this is called most of the time, 95% of the time, but occasionally you don't want to call transform, then you could make a bool. So we could say transform equals true by default, and then if we don't want to do it, we could say false. That would be a better way of doing it, instead of always calling these two lines together. And once again, this is a common mistake that people are making, that they are not polishing their code by consolidating functions and combining them into one and so on. I think I gave an example in one of the TensorFlow videos where they had, I think it was 4 function calls that always had to be written together. Why not just put it inside one function call? So this is a common problem. But anyway, let's continue. So this is the original code again, and we have the same problem here with nesting. Here we have the, what was it, rows or columns? Now I can't remember anymore, and they haven't written it here, all right? So is this a row or is it a column? Who knows? And then we have the case for the diagonal, I suppose, if I equals j, or the lower triangle, if I is greater than j. Let's see how I did this. So first of all, I make clear that we are now iterating over all the rows in the 2D plot matrix. Again, you might think this comment is too much, but it doesn't hurt. And this code is not written for somebody who is already an expert in the code, okay? This is an open source project. 5 years from now, I'm not gonna remember, I'm not gonna help you either fix this code. What I have done instead is that I have really made an effort so that you can do it yourself. You can understand it and you can modify it yourself. You don't need me to explain to you what it is doing. So again, I comment everything here, even when I call a function that I just defined above. Because if you're reading this code, you may not have read this function yet. And here I have decided to combine these two for loops. So we first do something on the diagonal, and then we do something below the diagonal. And again, note that I make a comment here, because this for loop is actually a little special. Instead of having these nested if statements, we can just change the loop conditions. Okay? So I explain to you now that we process all the columns in the matrix, but only until the diagonal, for column in range to the row. And this might be a little cryptic to read and understand what is going on, and I try to help you by writing a little longer comment in English. And then we do all the processing here, and again everything has been beautifully commented, so you can understand what it is doing, without looking up all the API calls. Now in all fairness, some of the code in this library is actually commented. I don't always think the comments are very good, and in this case I don't really understand what it is doing, but what I want to talk about now is something slightly different. Because you see they have made a line break here, and I think this is in order to get the lines to be less than 80 characters long. You see, it is just gone to 79. That is because the Python standard, which I think is called PEP8, will give you a warning if a line is longer than 80 characters. So if we do like this, you see it becomes 82 characters long, and then you get this warning. Now I ask you this, what do you think is prettier, this or this? The bottom line in what I'm trying to say is that you should try to make your code and your comments beautiful. And sometimes that means you have to break the rules a little. So you make a line that is maybe 2 characters too long, but it looks better. But actually, this line has some of the problems that we have talked about before. It would be much better to do it something like this. And actually, because this is a little complicated, you might even want to take that out as well. And then you might want to go up here, move it up here, and then explain what it is doing, blah, blah, blah. I don't really know what this is doing, so I would have to look up all of these API calls before I can even write this comment. So this would actually be even more beautiful. So my conclusion with all of this is that there's really no black and white for writing great code. You need to have empathy, and you need to have patience, and you need to understand that if you don't spend the time doing it now because you understand the intention of the code, somebody else 5 years from now will have a huge headache trying to fix your code. And what they're gonna do is that they're gonna go in with a debugger because it has crashed somewhere. They're gonna fix 1 or 2 lines, and because they don't really understand it, it just builds layer upon layer of poorly understood semantics, and you end up with tautologies or new bugs or certainly a whole big mess. So when you introduce new code to a project, take the time to try and make it beautiful. Explain what it is doing. Simplify it. Tomorrow, think if you can simplify it a little more, maybe explain it a little better. And you might say, oh, I don't have time for this. But again, the time you're saving yourself by doing it properly the first time will be paid back manyfold 6 months from now when you have to modify the code. And if you're working on a very popular open source project, it might have thousands of users. And if each of them is just wasting a few hours, then it is many thousands of work hours that could have been saved and used on something more productive because you have taken time to really polish and make your code really good and easy to understand. So, I hope this has been helpful. The intention was not to bash somebody's code. The intention was to give some input and some useful tips on how everybody can write better code. Because I see even Google engineers make some of these mistakes. So, pretty please, with sugar on the top, clean your fucking code.